All right. Hello, ladies and gentlemen. Today is the Unit 9, Day 13 notes, which is specifically on solving rational equations. So a little recap of what we've been doing before this. We've been doing problems where you're taking something along the lines of like an x plus 5, maybe over an x minus 3, and multiplying it by an x minus 3, x plus 4, and then maybe an x plus 5 on the bottom, something like this. And we said when you're multiplying, you're pretty much thinking of the top as one single piece, and then the bottom as another separate piece. So instead of thinking them as two separate fractions, kind of thinking them as more of a top and the bottom, and going through and saying, oh, look, I have an x minus 3 and an x minus 3, x plus 5, x plus 5. Therefore, my final answer would just be an x plus 4. So everything that we have been doing up to this point has not actually been solving, it has been simplifying. So we were not able to solve for x, we don't know what x is, but we know the simplified version is an x plus 4. What we will be doing today is actually solving these problems. So what is the difference here? The difference is these problems actually have that equal sign, versus what we had before was more multiplication signs or sometimes division signs, but today doing that equal sign. So going back to some of your previous knowledge from second grade or third grade when you first learned about fractions, you might have been given a fraction like this, and maybe it was a 2 over 3 equals a x over 7. Okay, so maybe this is in terms of pies. You have three, a pie that's cut into thirds, and you only have 2 slices right now. You need to give it out to 7 people. How many slices do you need? Something along the lines of that. So way back when you learned this, you learned of this thing called cross multiplication. This is not to be confused with normal multiplication, in which case we multiply straight across top and bottom. Cross multiplication is when there's an equal sign and you're actually multiplying diagonally. So a normal multiplication, you go straight across. If I had a 2 over 3 times an x over 7, I would go straight across and get a 2x over 21. So normal multiplication, you just go straight across. When you have an equal sign, you do this thing called cross multiplication, which would give you a 3x equals 14, and then you would solve for x and find x in that manner. That is actually what we will be doing today, is looking at fractions in that way. So now what we have is 2 pieces equal to each other. So we want to do cross multiplication. Again, this is not normal multiplication. It's not just straight across. This is cross multiplication. So you're going to get 7 times 4 gives me 28. And then on the other side, you're going to get a 3 times x plus 3. If I go ahead and solve this, solve it for x. My apologies, that should be a 9. Keep solving this through. That gives you a 19 equals 3x, and therefore 19 divided by 3 equals x. Now I put on here, don't forget to check them by plugging them back in. So you have the option of going ahead and plugging this in and having a 19 over 3 plus 3, and then that's going to give you a 7 divided by 9, or 0.3 repeating, which ultimately does work out to be the same as 3 over 4. Option 2 is to go back and think about your restrictions. What is x not allowed to be? X is not allowed to be a negative 3. Well, good thing, because I did not get x to be negative 3, so I'm good, everything's fine. Now if we go ahead and move on to the next example, okay, if you want to try this, I would recommend you pause the video and try it by yourself, but I'm just going to go ahead into working in it. This is multiplication, so I'm going to get a negative 4 times x plus 2 equals, now the 3 and the 5, I can just make that 15, x plus 2. Keep solving, negative 4x minus 8 equals 15x plus 30. Keep solving and you get a negative 2 equals x. And you're like, golden, yay, done. But actually go back to your original. Don't forget about your restrictions. So in your original, our restrictions would say that x cannot be negative 2. Well, that's counteractive, because up here we're saying that x can't be negative 2, but down here we got x to be negative 2. Well, so it is a solution, but it's not one that will work, because if you plug it in, that will give you 0 on the denominator. Even if we go to check this answer like we did above where we plug it back in, you're going to get 0 on the denominator. That's a problem, and therefore in this problem you have no solution. So again, you could have tried plugging it back in up here and seeing if it works, or just think back to your restrictions, and right off with your restrictions you see that this is not going to work. So for the most part, when you have problems that are just two fractions, one fraction, two fractions, with an equal sign in between, it's pretty straightforward, just cross multiplication. The tricky part comes in when there are a couple of fractions. So for this example, there's a total of 3 fractions. So we need to be thinking about what is our least common denominator, or as some of you know this as your LCM, least common multiple. So way back in Algebra 1 you learned about the LCMs, and if we said what's the LCM between 3 and 5? Well, multiples of 3 would be 3, 6, 9, 12, 15, 18. Multiples of 5 would be 5, 10, 15. What's the smallest one they have in common? They have a 15 in common. So the LCM would be 15. That's what we're referring to here as the LCM. But it's called LCD just because D stands for denominator. You have to be thinking about what's the least common denominator, not just multiples in general, but the least common denominator. So let's go back again to our previous knowledge in 2nd grade. Think back when you had fractions. Let's say you had a 3 over 4, and I wanted to add it to a 2 over 12. Okay? Well, right now, this is a 4, this is a 12, so they can't really be added together unless they have the same denominators. So how could I possibly fix this problem? Well, I could take the 4 and multiply it by 3. That would give me 12. But if I do it on the bottom, I have to do it on the top as well. So this would give me a 9 over 12 plus a 2 over 12, and then I could go ahead and add them. That's actually what we will be doing in this section, is that idea of trying to get them to be the same denominator. The only problem is now there's x's thrown in there. It's not as simple as just, making it a 12, but actually having that x involved. Think of x as just another number, okay? If this is a 3, maybe this is something else. But in order to get an LCM or LCD, you basically just want to take all of your options of denominators, the 3 and the x, and multiply them, and that's going to be your LCD every single time. So here I know my LCD is a 3x. So now what we need to go through is in each of these fractions say, how can I go from an x to a 3x? Well, I can multiply it by 3. So let's do that on the top and bottom. That's going to give me a 6 over 3x. In the next problem, I have a 3, but I need it to become a 3x. So what do I need to do? I need to multiply it by an x, top and bottom. So now what I'm going to have on the top is going to be a 5x, and on the bottom I'll have a 3x. And then last but not least, don't forget about the other side. This one already has an x, very similar to over here. So I want to multiply it by a 3. That's going to give me a 21 on the top and a 3x on the bottom. Now what's nice about this, oops, my apologies, give me a second to go back up. There we go. Oop, too far. Sorry about this. Okay, there we go. What's nice about this is now they all have a 3x on the bottom, so no matter what, the bottoms are going to be the same and you can kind of ignore them, which means I now have a 6 plus 5x equals 21, and solve it, just like up top. That's going to give you 5x equals 15, x equals 3. Now, if you're in class or if you've seen this once before, you might have done LCD in a different way. There is a second option as far as how you could possibly solve this, and that is to choose your LCD just like we had, but take each of your fractions exactly as is and simply multiply them by this LCD. So if I multiply this first piece by a 3x, think of it as like a 3x over 1. I want to multiply it by a 3x, and I want to multiply this one by a 3x. Now this one you're not doing top and bottom. This one you're simply just saying I am multiplying each of these by 3x. Now 3x, this LCD is technically over 1. That's why I'm kind of saying over 1. And with multiplication of fractions, going back to yesterday, we just multiply straight across. So this is going to give me a 6x over x. This is going to give me a 15x over 3. And this is going to give me a 21x over x. Now that you've multiplied straight across, you could go through and simplify. These x's cancel out. Over here, the 15 and the 3, that's going to become a 5 and a 1. And then over here, the x's cancel out. So what am I left with? Well, I'm left with a 6 plus a 5x equals 21. And look at that. It becomes the exact same problem as we had over here, just going about it in a slightly different way. Now, some people will choose to reduce before they even multiply. That's your choice when you want to reduce. But here's two different options to how to solve one of these problems. Now, if you go on to the next page, you'll see two more examples. I might not do these entirely, but I would like to stress what the LCD for each of these are, because you will see problems like this. And I would say finding the LCD is the hardest part. The process of solving is not necessarily hard, but picking out what the LCD is kind of the hardest part. So frequently I just start with the numbers, and I say that I have a 5, a 3, and a 3. What's their least common multiple? So think of the 5s. You have 5, 10, 15, 20. The 3s, 3, 6, 9, 12, 15. Oh, look, 15's in common. So your LCD is going to be 15. Now, they also share an x and an x, so I can tack on an x, and there's my LCD. This one, kind of think of these as two separate pieces. You have an x in one piece, and then in a separate piece, you have an x plus 1. So over here, these were both single x's. Kind of think of this, I'm just saying visually, you could think of this as being so different that it's like an x and a y. These are two separate things. Just because this has an x and this has an x doesn't mean that they're related. Think of it more as just two totally, it's like how people always get confused with an x and an x squared. If you try to add these two things, they are different things. You cannot combine them. So when you're looking at this piece, just because one has an x and so does the other, doesn't mean that they're the same thing. One is an x and one is an x plus 1. And if you recall, we kind of want something from every piece. So in this case, you want the x, and you, excuse me, you also want the x plus 1. So that's going to be your LCD. And then decide how you'd like to finish going through this problem. I'm going to stick with this one just because the 15x is very similar to what we did on the front. This one here, I'm going to go with the option of multiplying every single piece by an x and an x plus 1. So I'm going to have x plus 1, and I'm going to multiply it by 4x. Now in this case, the x's both cancel out, which means my final answer is going to be a 4 and an x plus 1. Then I subtract, so I'm going to go on to my next piece. I'm going to again multiply it by an x and an x plus 1, and that's going to be a 3 over x plus 1. Well, in this case, the x plus 1's cancel out. That means I'm going to be left with a 3x. And then on the other side, the only thing that I have is a 1. So when I take 1 and I multiply it by an x and an x plus 1, it's just going to be x plus 1. And then going through and finishing out this problem, on the other side you're going to have an x squared plus x. This will simplify to be a 4x plus 1 minus 3 x squared plus x. Keep working through this all the way through. You're going to get 0 equals x squared minus 4. Now, this is a difference of perfect squares, so if you remember how to factor this, you should get a minus 1 and a minus 2 and a plus 2, which means x is going to equal a 2 and a negative 2. Now remember to check that with your originals and make sure that you don't have any problems. So if I go back up here, I would say that x cannot equal 0 and x cannot equal negative 1, which I didn't get either of those answers, so my answers should be good, and I've checked them. Okay, so again, your homework tonight is from the book. Make sure you check that out, and we will have 2 more practice days, so plenty of time to kind of get a good grasp on this whole LCD concept.